Welcome to aminacademy.com. In physics, let us discuss about an electric field. What is the meaning of electric charge is quantized? An electric charge is quantized, which means that the charge of any object can only be an integer multiple of the elementary charge or E. The charge cannot have any arbitrary values but must be an integral multiple of E, that is 2E, 3E, 4E, like, but it is not in terms of half E, 0.5 E, 0.3 E, like, which is equal to 1.6 in 10 raised to minus 19 coulombs. For example, an object charge can be exactly 0E, that is no charge, or exactly 1E, minus 1E, 2E, 3E, like, but not half E, 4.8 E minus 5.2 E, like. That means it is integral multiple of E only. The magnitude of the smallest charge ever measured is denoted by E, which is called quantum of charge. Here, quantum of charge. Quantum of charge, that is called E, you know that, which is equal 1.60218 into 10 raised to minus 19 coulomb. Next one, conservation of charge. Conservation of charge is the principle that the total electric charge in an isolated system never changes. It's a constant. The net quantity of electric charge, the amount of positive charge minus the amount of negative charge in the universe, is always conserved. Means the algebraic sum of charges in the universe is constant. When the particle with charge positive E is created, a particle with negative charge is simultaneously created in the immediate vicinity. When a particle with charge plus E disappears, a particle with minus E also disappears in the immediate vicinity. Hence, the net charge of the universe remains constant always. The test charge concept. Now let us discuss about the test charge concept. The test charge is a small positive charge used to measure the strength of the direction of an electric field at any given point. The charge is so small that its presence does not affect the electric field created by the source charge. The direction of the force experienced by the test charge at the point is the same as the direction of the electric field at that point. Suppose here test charge is there, that is, let it be positive charge. Here the source charge is also positive here. Means a test charge is a very small charge that can be used in making measurements of on an electric system. It is assumed that such a charge, which is tiny both in magnitude and physical size, has a negligible effect on its environment. Next is an electric field. What is an electric field? An electric field, an electric property associated with each point in space when charge is present in any form. The charge, the magnitude and direction of the electric field are expressed by the value of capital E, called electric field strength, or electric field intensity, or simply the electric field. Here, surrounding the charge, electric field created. Electric field is said to exist at any point in space when a test charge placed at that point experiences an electric force. The direction of the electric field at a point is the same as the direction of the force experienced by a positive test charge placed at that point. Electric field lines can be used to sketch electric fields. The line through the point has same direction at that point as the electric field, where the field lines are closest together. The electric field is largest. Field lines come out of positive charge because a positive charge repels a positive charge test charge. Like charges repels each other and come into negative charge because they attract the positive test charge. Next is an electric field due to point charge. An electric field due to point charge is a vector field that has units of Newton per coulomb. It's defined as the electric force acting on a positive test charge placed at a point in space divided by the test charge. The direction of the electric field is the same as the direction of the force on the test charge. Now, the electric field strength due to point charge electric field, we can write this as Fe here. Force on electric charge is equal Q into vector E. If Q is negative, Fe will be opposite to that direction to vector E. Next one, an electric field due to point charge. An electric field due to point charge is a vector field that has units Newton per coulomb. It's defined as the electric force acting on a positive test charge placed at the point in space divided by the test charge. So, Fe equal 1 over 4 pi epsilon r square q on q days equal q days into 1 by 4 pi epsilon r squared. But if a point charge q is placed at a position where the electric field is E, then the force q is Fe becomes 1 by 4 pi epsilon r into q or square into q. This is the electric field at a distance r from the point charge q. The same relation applies at points outside a finite spherical charge q. Superposition principle. What is superposition principle? The superposition principle states that the total force in a linear system is the vector sum of all individual forces acting on it. In Coulomb's law, the stimuli are electrostatic forces which depend on the distance between two charges and the magnitude of their charge. The superposition principles allows Coulomb's law to be extended to include any number of point charges. Look at here. This is the superposition, explaining the superposition. The force experienced by charge due to other charges is the vector sum of the Coulomb forces acting on it due to these other charges. Similarly, the electric intensity E vector at a point due to several charges is the vector sum of intensities due to individual charges. So far we discussed about in electric field superposition principle, an electric field due to point charges, an electric field, and the test charge concept, and conservation of charges. Electric charge is quantized like that. We have done. Please subscribe our YouTube channel.